easy potatoes. We had a potluck last period.
What class did you have?
Journalism. We had the whole period.
Journalism?
Yeah.
Cassie, you want me to?
We didn't do anything else. So, Connor, you better shut up before I sit on you.
You know?
Oh, yes, sir.
And the player I'm getting plays tonight. The trade isn't good until tomorrow, which means I'm not going to get it until next Wednesday. Or next Tuesday, actually. Because he already played, so I can't trade him.
So I did this.
And I wanted him against the Spurs.
Technically, I'd say I'm for this week or not.
Yes. You like your new phone?
I do.
You enjoy it?
It's, yeah.
Will you tell me the different qualities yet?
For what?
The iPhone, the iPhone
Huge
stuff.
processor, camera changes, big camera changes. Basically when
Is the Zoom crazy?
actually the zoom is not as crazy as I thought it would be. It does better in low light, I'll tell you that. It does do better in low light.
Can I take a picture of the moon yet?
Oh, what?
Of the moon?
You can always take a picture of a moon.
No, it never turns out. It's always a little
Well, I didn't
off.
say that it was going to turn out. I just said you could take a picture.
Can I take a good picture of the moon?
Hey, Connor.
That's all I'm looking for in my next phone.
All right. I'll test it out someday when it's
Yeah, I'm way overdue for a new phone.
okay.
You say when it's not
Bro,
ready? 'Cause I don't
Is it
think
the
that's
same
right.
size as like a 6?
So 6S Plus.
So can you put like a 6 case on it?
No, the camera bulge is too big, and because the camera bulge is basically the same as the hole that used to be. That's just the camera now, and so the flash is still even further past that.
Wait for 7?
I know, I was gonna take a Dremel and like just make my case bigger for that spot and just put it in there, but then the buttons are just, the buttons are the same, but they're a little bit further out, so I'd have to Dremel up the holes for the buttons too. And at that point I was like, nah, this
Too much work.
yeah, too much work, and I can just buy a case of Amazon for like $2.
The 7's huge also, not just the 7 Plus. Just the straight 7 too.
No, 7's just the, like the 6S, and then the Plus is on the same place.
Okay.
So, yeah, they're respectively this. All right, so we're on section P.6 today, which is called rational expressions. Okay, there's a couple different things I want to talk about today. Obviously, we need to first define through the definition what this means. So, what is a rational expression? What does it look like? Then what we're going to do is we're going to hit up a couple examples today of rational expressions themselves. So we're going to look at the basic operations with them: add, subtract, multiply, and divide. That's what we're going to look at today. Now, I don't know how far past that we're going to go. Past basic operations, because there's a couple things that we want to eventually get to, which is, instead of just doing basic operations, one of the main things that I know that I want to cover, and I don't know if we'll cover today or tomorrow, is complex expressions. Okay, so this is something that I know for a fact you have seen in Algebra 2, which is, I personally believe in Algebra 2, that complex expression is probably the most difficult section to look at. Just to look at. It wasn't difficult to do math-wise, just to look at, because there's a lot of things going on. I'll show you my little rules for how I attempt them, that type of thing. And then what we'll do is, eventually, like tomorrow for sure, there's one particular problem that I want to discuss, which is, it's based on a limit problem. It's based on limits, which we'll discuss what that means. That is a perfect calc topic, and that's where this stuff really fits, is calculus. Okay, so that's why that'll be my topic tomorrow, just to make sure that you understand like where this is going to fit in the big scheme of things, why we need this. Today, my goal today, if we can, I just want to make sure we cover the basic operations. Can we do that, and can we get them correct? Okay. What we'll basically do today is when we're going through these basic operations, I'll allow you guys to pick problems out of the book. That's what we're going to do. I'll just pick a couple problems from there. We'll do a couple on the board just to show you kind of each type so that you feel comfortable with them. And if there's a certain type that you want to look at still, we'll keep trying that type of problem until you get good at it. Does that make sense? So today is kind of like it's really just kind of a, what fits you? What do you need to see? And how do we need to do it? So if you have, take out your textbook if you have them, and we're just going to start with an addition, subtraction style problem, okay? So, that's what we're gonna start with, but, before we do that, so have your book out, don't get me wrong, have your book out, so if you have it with you, that's fine, if you don't, not a big deal, you can just look up your neighbors. Let's define what a rational expression is first. So, definition. Okay, now, obviously, an expression itself is numbers and letters combined using basic operations. Correct? That's what we talked about from, I think, the first section of this chapter. I mean, you did it in Algebra 1, you did it in Algebra 2, and so on and so forth. But what it means to be rational, it's written in fraction form. So, it's numbers and letters combined using basic operations. Written in fraction form. That's kind of the idea. That's the definition of what a rational expression is. The big idea with rational, we've seen rational numbers before. That was like one of our topics in the first section was to talk about this different sets of numbers, the sets of real numbers we discussed. It was kind of a topic we did in geometry and algebra 2 and so on. Rational numbers are anything you can write as a fraction or like a repeating decimal or a terminating decimal, correct? Well, we're not just doing numerical expressions. We're not doing numerical, we're doing these for algebraic as well. So here's what I'm talking about. It'd be something like this. That is a rational expression. It's got things top and bottom, there's variables, there's, you know, different operations going on there. Now, the main thing that most people always attempt, that they get wrong, is they look at that problem and they try to cross out things, right? Like, what's your first instinct when you look at that? Yeah, get rid of the 5x's, right? You're not allowed to. The reason being is that the 5x on the bottom is attached to the plus 2. It's a binomial. The only time you're allowed to simplify an algebraic expression, like a rational expression, is if things are being multiplied together, parentheses wise. So something like this. So if they're written with parentheses, now you can cancel things out. Because now if it's the rule of simplifying, that simplifying works with division, these items can be divided out because they're separate. It's not being added to something, it's literally being divided out. So that's just something you need to realize, that you have to like factor things apart, which is why we did all that factoring stuff the last couple days in here. And then once you have it factored, you can see, do they have anything in common? Now, the only way that 5x can go away is if there's like the variables on the outside by themselves. Something like, let's say like x squared out here. Now, the x can go away, and this 2 can turn into a 1. Because you simplify it by normal division rules for variables. Okay, I've definitely seen this situation before, and it always makes me laugh. So, say that this is my problem, right? So, you know, we've crossed out the back parentheses. What do we do with these? With this? X's. Just the x's go away. Like that. So the 5 just stays out front, the 4 just stays out front. Right? I've had people in the past, and it always makes me kind of laugh, because I understand the rational thinking behind it. Is, yeah, they attempt to do this, which I just kind of makes me chuckle. They get rid of 4 down here, and they make this 1x up top. That's not what you do. It's not how you do variables. Variables don't work that way. Variables, when you cancel out variables, you use powers. You know, 4x to the first. You cancel out the powers of variables. That's how you subtract variables. The numbers are just out front, and you're just looking for what things have in common. You guys on my yield, kids? questions with the idea of like canceling out variables? Now, obviously, the hardest part about this stuff is the factoring. That's what gets tough, like pulling things apart, knowing the 5 different ways of factoring. You get common factors, trinomials, difference of squares, cube, and grouping method. To get it to look something like this. Then you can start canceling out parentheses, but they have to be multiplied together. It cannot be the thing where you just notice that problem like this, so go back to this original problem, the one we started with. You're not just allowed to cross out these. That does not work. Okay, that's not how you attempt that problem. It's like that. Okay. Any questions, comments, concerns on the basics? That was just the introduction to what we're about to do. So we're simplifying fractions into the simplest form. Okay. But again, we're dealing with all the different basic operations we can deal with. Okay? All right. So, let's start with the basic operations stuff here, and we'll start with adding, we'll start with subtracting, and then we'll see if we can eventually get to multiplying and dividing today. That's what I want to get to. Okay. But before we do that, before I start asking for problems out of the book, we need to do a crash course on how do you add fractions together. So I'm just going to make up numbers. So 3 out of 10 plus 2 out of 7. Okay. How do you add fractions? Common denominator. You don't just add straight across. Don't make that 5 over 17. Not how you do that. It's not smart. So you have to find common denominators. So the common denominator between 10 and 7 is 70. That's the least common denominator that they both have, right? Because how you do that? You find multiples of 10, you find multiples of 7, you find the first one where they match. That's just how it works. So they match at 70. The trick is just multiplying together. That's the easiest way to think of it. But it's different if you have variables. We'll discuss that here in a second. On the top, when I change this to a 70, I have to multiply by 7. So I have to take the top times 7, I have 21. Over here, I multiply by 10, so I take the top times 10. So it turns out to be 20. Now you can add straight across. And when you add the top numbers, that's what you have. You have 41 out of 70. That's the idea. Okay, how I always describe like adding fractions, that it makes sense to me. It's imagine you had 2 different pans of the same type of like brownies or cookies or whatever you have. Okay, I usually go with brownies, right? You're trying to combine these pans, and this is what it looks like. The pans are broken up. Like this pan is broken up into 7 brownies, and there's 2 of them left. This pan has 3 out of 10 brownies. That's how they cut it. They cut it into 10s. So when you try to add them together, you can't just jam all the different brownies together and offer it up for the next person in line, right? It doesn't look clean. So if you want to make it perfectly spaced, you try to find the common number of brownies that can fit in those pans. So you cut all the brownies into the same exact size, so it's fair to everyone going through the line. And so the only way that you can break up these things correctly is if all of the pieces are in like 70 individual pieces would fit in one pan. And then when you did that, this top pan turned into 21 little pieces. This pan turned into 20 when they're all the same size cubes, whatever it is. When you add pans together, now you have 41 total brownies in that pan. And there could have been a total of 70. You'll see that. Now, obviously, if people are cutting brownies, they don't really think about this. They don't think about the numbers. They just cut them in the same size. They don't even think about it. Okay, but that's my mental process for doing it. Like you're trying to get the brownies to be the same size, and how many do you have total now? That's the idea. Okay. Any questions with adding or subtracting? Subtracting is the same rule. I mean, subtracting, if you just change this to a minus sign, you follow the same rule. You get common denominators, and now the answer is just 1. 1 out of 70. You subtract. Okay. So let's apply this to now. Let's do this with algebraic expressions. Let's do something with variables now. How we can get common denominators with variables. So what I'm going to do is we're going to jump right in the deep end. We're going to look at what some of the problems are in your book and see if we can attempt to show you how it works with finding common denominators. We'll try different styles of problems. We'll try adding and subtracting first. Okay, maybe we'll do 1 or 2 of each. So that way we get good and feel comfortable with it. Then we'll move on to multiplying and dividing if we can. If we don't get there, it's fine, we'll continue tomorrow. But my goal tomorrow is for sure to talk about complex if we don't get there, and this idea of limits, like where this would fit in the grand scheme of things with like calculus. That's a calculus. We may see an assignment tomorrow, but it won't be due until like middle next week sometime, like Thursday or Wednesday. So, just because next week there's so many things going on homecoming wise, I don't want to do a bunch of homework next week. We keep it as minimum as possible. So,
I wish all teachers had that mentality.
and it's just it's hard enough to make when you're in everything. You're here all night doing decorations. So, okay. So here's what I want. So somebody has their book. I want you to look. I think we're on page-ish. Let me open up the book here. I'm on roughly. It's right past page 70 something. 71. No, it's way past that. It's page 79. Okay, so 79. Yeah, so 79. I want a problem where we have to add things together. So I don't know if they're on that page. They might be on the next page over. Yeah. So turn the page, go to page 80. At the very top of the page, there's a couple problems there where we have to add and subtract things together. Okay? There's only probably about 6 of them, right? Let's maybe do 1 or 2 of them. Okay, so let's pick an addition problem. So there's only a few. 86? 36. All right, let's do 36. So somebody, we pick 36. What do we got on 36? We have x squared minus 4x.
Over x squared
Minus 7x.
minus x minus 6
Minus 6, okay.
plus
Plus
4x minus 4
all over
x squared minus x minus 6.
minus 6.
Mhm.
Okay. All right. So here's what I would do. First thing, do they have common denominators? Yeah. So if they have a common denominator, you're allowed to add the tops together. If they did not have the same denominator, this is where it gets tricky. We'll try to pick the second problem we try to pick. We'll try to pick one where it does not have the same denominator, and where we have to make it work. And I'll show you the process for how I do that, the easiest way I can show you to do that. Okay, because right now this is perfect. They worked out. So when you add, you just add the top together, and the bottom will just stay the same. That's how it works when you add fractions, right, or subtract them. So that's going to be your denominator, right? That's easy. It's nice to see that. The top now, we have to add these things together. So you're adding this item and this item, yeah. So the 4x's literally cancel because it's a negative 4x plus a positive 4x. So that's just x squared, and then you have that minus 4. Okay, any questions so far? You're not done though. Okay, that was the first step you have to do on these problems. You have to try to find what is the numerator with the denominator. The next thing you have to do, once you add these things together, and hopefully this made sense, that's how we add that, right? The next thing you have to do is now you have to simplify it, if you can. And what I mean by simplifying is not just crossing out things. Don't just cross out the x squares all willy-nilly. Like, you can't do that. What you need to do, you need to factor. You need to factor these things apart. This is the only way that you can cross out things. Because right now, things are being added and subtracted together. You can't do that. You can't just cross out things. So what we need to do is we need to factor. When you have individual factors, things that are multiplied together, that's when you can cancel stuff out loud, or cancel stuff top and bottom. Because it's like a problem like this. Like if you had 12 over, let's go 12 over, let's see, 42, something like that, right? What the real process for doing this is breaking down 12 into like prime items, things that are multiplied to give you 12. So it'd be like, the prime numbers for 12 is like 2 times 6, and then 42 is like 2 times 21. And then you keep going, you keep breaking those down. 6 is 2 times 3, then you break down the 21 to be 3 times 7. And then what you do is once you get to this step where all these things are multiplied, you can cross out things that perfectly match. And so your answer is 2 out of 7. Like that's how you do it, right? You get to factors, individual items. That's what we're going to do here. Right now, these things are all being added and subtracted together. So I need to first break these things up into perfect factors, things that are multiplied together like this, into their prime where they can't be broken down any further. Then you can cross out the things that they have in common, because that's your common factors idea, right? So to to do that, the top, I already heard it, somebody already said that. Difference of squares on the top. It's two items, it's a binomial and the perfect squares is, it's two parentheses, plus minus, x and x, 2 and 2, right? The bottom is a trinomial. So on the bottom, we do the trinomial rule where it's plus minus is the back symbol. The x squared breaks it to be x and x, and then I have to break it to 6 to be two numbers that would give me a -1. So 2 and a -3 here. That will multiply, give me 6, but give me a -1 in the middle. And now what I can do is I can see, do they have any parentheses in common? Yeah, they have these, right? You can cross out the whole parentheses because those things are multiplied. So this is your final answer. That's what I'm going for. You can't go any further. Don't cross out x's right away. You have to break it apart to find the factors, the individual prime items that make this thing. Okay, any questions of that problem? Okay, let's do one now where we don't have a common denominator. That was kind of easy, right? I don't care if it's adding or subtracting. Let's pick something where the bottoms are most definitely different now. So this. Is there any that really have any
41.
different?
Yeah.
41.
41? Yeah, do that. Just give me a glimpse of how this works. All
3
right.
over x plus 4.
Say it again.
3 over x plus 4.
3 over x plus 4.
And then plus 6 over x plus 5.
Okay, perfect. Okay. So, I don't care if these things are more difficult looking or whatnot. You have to get common denominators. Common denominator, how I do this, if they're not matching. The first thing I would attempt is factor this thing apart if it can go that route. Like, if this is really big, like a trinomial or a difference of squares, a cube, or grouping, you factor apart. Now, can I factor that thing apart? No. Okay. So, I'm not going to be worried about pulling these things apart like this, all right? Because there's nothing to factor. Over here, can I factor this thing apart? No. All right, so now at this point, what we need to do now is get the common denominator. So the common denominator, since these things are completely factored, is you pick the individual parentheses. So what are the different parentheses you see on the bottom?
X plus 4.
Exactly. You pick every different one that you can find. So these are the different ones that we have. And over here, same thing. X plus 4, x plus 5. Those are all the different items that you see on the bottom. Now when you do that, now I don't even care if there's more parentheses up here, there's letters on the outside, if there's more parentheses and letters on the outside. You pick every individual different item you see, and that's what goes on the bottom of everything. Every individual item. And if they're squared or whatnot, you have to pick the squares. They have to be matching. Okay, so you have to have the same number of them. Okay, so now, did I introduce something new here? Yeah, what did I introduce? X plus 5, that has to also go to the top. Because whatever you change on the bottom also has to change on the top. So that way it's still a balanced expression. Because technically what I did is I actually multiplied this fraction by the number 1. By multiplying that little expression by 1, it didn't change the answer. But instead of picking a 1, I picked this, which is really complicated looking. X over x plus 5 plus over x plus 5. So that's what I did. Over here, did I introduce something new? X plus 4, you have to do the same at the top. The same rule. I'm multiplying by the number 1 on that fraction, so I'm not changing it technically. It looks like I am, but I'm not. Now at this point, now I can add or subtract this thing together, because the denominator is the same. The denominator is this. So that's good. I'm done with that. The top, though, I have to add those things together. So I'm literally adding the 3 times x plus 5, and I'm adding that to the 6x plus 4. That's what I'm doing, right? I'm going to need to FOIL and distribute and all that good stuff on the top. The bottom, don't care about it. Leave the bottom alone. The bottom is fine. You're working with the top only. So what I'm going to need to do first, so I can actually add the top so it doesn't look like this complicated mess, I need to distribute the 3, distribute the 6. Okay, does that make sense to everyone? Because now my goal now is, now that I've added them, I need to simplify this thing down as far as I can, if I can. So this turns out to be a 3x plus 15 plus a 6x plus 4. And on the bottom, I have the x plus 4, x plus 5. And we we see, can this go any further than it will? Oh wait, sorry, that was a 24, sorry. 24, sorry. Can't multiply in my head. All right, so 3 times the x, 3 times the 5, x times this, 6 times x, and the 6 times the 4. All right, now at this point, I'm going to try to add these things together. So if I do this correctly, it looks like I get 9x plus 39 all over x plus 4, x plus 5. Right? Is that correct? Did I add these correctly?
That's right.
Okay. What?
That's right.
All right. And if you can, that top, now that I've added it, if you want to see, can I cancel anything top and bottom? Well, the only way that you can try to is if this parenthesis on the top exactly match something on the bottom, which it doesn't, or they have something in common. They have 3. So if I pull the 3 back out, this is what I'm left with. And I try to see, can that cancel out anything, which I know is that's like an extra step. But that's if the top turned out to be really, really, really complicated looking. You try to factor the top to see if it could actually multiply. Because again, you're trying to combine everything up here, and once you have this combined, then you have to factor it apart correctly. That's kind of a rare step. Usually that doesn't happen. Usually, like when you added this stuff together, usually it turns out to be something that you notice match the bottom. That's kind of the idea. Yeah, but either one of these are the correct answers, because you can't do anything with them. So don't foil the bottom, leave the bottom alone, especially when you have them all separated. That just wastes time. Okay, any questions, comments, or concerns with adding and subtracting? Like this is the style of problems you have to get comfortable with. Like something like this. All right, now let's move on to multiplying, because multiplying is a lot easier. You don't have to find common denominators as much. Multiplying, you just go straight top and bottom. So let's just talk about very easy multiplication. So just numbers, numerical expressions, not this algebraic stuff. If you're going to multiply fractions that are just numbers, like this, you just multiply it straight across. That's how multiplying works, right? That it goes straight across, you multiply both top and bottom, which is different. And then at this point, you'd see, do they have anything in common? You could have done that earlier. When you're multiplying things, you can simplify things, like first, top and bottom, or diagonally. You can simplify things if they have anything in common. But if they don't, just go straight across and multiply. And this is your final answer. Like that's what you should get to. If you simplified before you started, your answer will be done in the very end. Like you shouldn't have to worry about factoring and pulling anything out and whatnot. So, but that's how you multiply. It's definitely different than adding, right? Adding to the bottom doesn't change. Whatever your common denominator was, it stayed the whole time. But multiplying and dividing, you have to go straight across. Okay, so what we're going to try to do here, we're going to try to attempt to do a couple problems where they're multiplying things together. Not dividing, just multiplying today. And this might be my last 2 problems that we'll try. And we'll stop there and we'll finish with division tomorrow. So, all right. So somebody go to back to page 79. Let's pick a couple problems where they're multiplying on that. So yeah.
X cubed minus 8 over x squared minus 4 times x plus 2 over 3x.
Like that. Okay. All right. So the first thing that I would do, you could just multiply straight across, or what I would attempt to do is before you just multiply straight across, I would try to attempt to simplify this thing, like top down kind of thing, or diagonally kind of thing before I multiply it straight across to figure out what this thing is equal to. Because if you simplify it first, you don't have to factor it later. It'll be done. That's just the way they work. So this top here, this item is a cube rule. So when you do the cube rule and I'm factoring, it's a small parenthesis, big parenthesis. The bottom is the difference of squares. Over here, can I factor anything over here? Top or bottom? That's a simple binomial, there's no common factors, and the bottom is just a single terms, you can't even do anything with that, so. So that item over there is done, I can't even do anything with that unless something crosses out later. Because technically, these are in parentheses, they are already factored, there's nothing you can do there, so. All right, but over here, I need to factor this thing apart, so how the cube rule works on the top, the minus sign will stay here. You take the cube root of x to the third, which is x, the cube root of 8, which is 2, and those are the numbers I'm going to use for the rest of the parentheses. So it goes plus, plus, right, because it goes the opposite sign, and then plus sign in the back. Here, in this part, you have to take the first item and square it, so that's x squared. The middle is these two multiplied together, so that's 2x. And the back is the back item squared, which is a 4. And that should not be able to factor any further. That's completely factored. Down here, this is difference of squares, plus minus, x and x, 2 and 2. And now, we look top and bottom, top down, I always do that. Is there any parentheses that match? X minus 2, those go away. Those are gone. Okay? I always attempt to do that first. Okay? Is there anything diagonally that matches? X plus 2's, those are gone. So your final answer, now that I have everything canceled, simplified up and down, diagonally, now you can go straight across and you can write down what your final answer is. My final answer in this particular problem is this. It'll be the x squared plus 2x plus 4 all over the 3x, and that should be done. That is completely factored. You can't go any further with it. It is simplified as far as it can go. That's why I always attempt. This is my rule for when I do these. That's like what I always do. Because you don't, because I know some people, they look at this, they go straight across, they multiply right away, which is correct. I mean, you could technically do that. And then they try to factor it up later. Super hard to do that. It's just super difficult. So just factor it first, cancel stuff out, then you can multiply across. Now, this rule, what you're seeing here, only works for multiplying and dividing. Doesn't work for adding. You can't do that for adding. So adding, you got to get common denominators, add them together, and then you can go from there. Okay. Any questions with that problem? We'll do one more, and this will be my last problem today. Last one. Very easy. We'll be done it really. You can work on that homework that we have to do today, if you need to. Okay. All right. So another problem, please. Anyone can pick. Try to pick from that page 79 area. X squared minus 4.
Over x squared minus 4x plus 4. Times 2x minus 4 over x plus 2.
Okay, do that. Okay. All right. So we agree this is a multiplying problem, correct? Not adding or subtracting. Okay. What is my rule that I usually teach? That? Yeah, simplify before zero. So you should factor these things apart if you can, and then simplify top down or diagonally. That way it makes everything kind of go away, and then your last thing is you just multiply straight across. That'll make this problem so much easier to start with that these problems will seem easy. They'll be easier than adding and subtracting sometimes. So, right here, I'm going to factor that apart. What is that? Difference of squares. So, plus minus x, 2 and 2. The bottom is a trinomial. It's going to be plus, or it's going to be minus, minus, because they're the same symbols for both minus signs. It's x and x. 2 and 2, so I'm going to make 4 in the middle. And then over here, can I factor this apart? 2 out of the top. So if I take a 2 out of the top, that's x minus 2. And then on the bottom, I have an x plus 2. Okay, so I factored everything up. Factoring the common factors, trinomial, difference of squares, whatever you got. Now you can cross things out diagonally or up and down. I always do up and down first. So up and down over here, the x minus 2's are gone. Anything? No. Now we can go diagonally. X minus 2, x plus 2. And so now I've got all those parentheses gone, so I just go straight across. The top is a 2. The bottom's technically a 1. There's nothing left down here, so your answer is just 2. Okay, you don't need to write this. I'm just showing you what it is. So the reason I do this, why I always write it like this, is because sometimes if that 2 was on the bottom, some people will think that their answer is 2 when it should have been half. So you always go straight across and write down what that answer is, even top to bottom. All right, questions, comments, concerns on anything we've talked about today so far? Today was kind of a crash course in like my rules for how I attempt to answer questions, how to keep it as easy as possible and to manage it. Tomorrow, we'll start right away tomorrow where we'll discuss, do you want to see a certain type again? Do you want to see adding or subtracting? I'll make up problems tomorrow. You have some different ones. And then we'll look at division tomorrow, and then we'll look at the complex idea. And I'll show you my rules for how I attempt complex. Okay, the rest of the time is yours. Quick reminder, who's in student council in here? Okay, I'll be sending an email today. I think Chance already did send one about the lunch sign up for aggressive days, because we have to mark out students who dress up next week. So she needs that form filled out today, just to get an idea like when you have lunch, so we can get kind of working. We just need people to stand there. And then I'll send an email reminding you of like, all your contacts, if you have a driver or a student judge or flowers, just make sure they're done, they're ready to pick up for next week, or even if they will be ready, so we can pick them up sometime next week and we get that time. And my email will have a ton of stuff, and then I'll send out a mass email to all kids about dress kids, sign up for kind of war, all that good stuff next week. A-frames you can pick up today or tomorrow.
Hey, I'm
He was
here
just like
at
disappointed,
7:45.
not like at you, but like at everybody,
Yeah,
because
that's a part of
like
it.
we have lab work today too. So
And
everyone,
it's a
everyone,
hot
you
lunch.
guys
Yeah,
do
I had to
it
get my
because they get
pay
somebody.
Make signs for that.
Wait,
Goes
for
a
what?
long way, and like tell every senior about it. Because that's your responsibility to advertise that.
Do
And
tug
it's
of
a
war.
help, they have to bring the food, and you guys just help.
We don't have anyone doing tug of war.
And then let go of the rope at the
You know how like, you guys check
Well,
off
if
people for
I'm
dress up
freshman
days
year,
at
back off.
lunch?
Yeah.
That was.
What if I don't eat lunch? What if I just sit down and like, yeah, we're
Alright,
That's fine,
good.
you still, you can go through the line, just make sure you get counted when you get sit.
We're still on spirit.
So you know how you're walking in, feel like, just go to one of the different say, I'm not eating
I did it
today.
right here.
Okay.
I literally crossed the floor. I don't care. I was
Say, I don't care.
I was walking alone. I study crap about every year.
Oh, I forgot about the last one.
Sixth period? You just
So
said.
we have to-
Monday, I'm excited about that. Oh my gosh.
Sixth period
I know,
anatomy,
that's
just
awesome.
class 6 is that meeting.
It goes like,
So
So we
we're
already
gonna
did
review
so
tomorrow,
we're
we're
done.
gonna review today,
what period is it?
and test is Monday.
All right.
Yeah.
Neither do you.
Like you like.
Everybody gets a
I
six
just,
period.
oh, I find out. I don't like
Tomorrow is just a study day, like
What?
that's. So,
Because he would wait hard. He would wait. I had to.
Can I ask my stand up there for a second? So I can count.
We're going.
yeah, there's only synonyms.
Right in your way, but.
Because it'll be like, which word nearly means this?
Not in the